Hello everyone and welcome to another part of the Galaga SDL tutorial videos, and in this video we're going to automate the diving formation. So we're going to make the butterflies, wasps and bosses start diving, but instead of setting it on a key, we'll do it automatically inside the level class. But the first thing that we need to change is actually a fix in the framework itself. In our GameEntity.cpp, there is an issue with the rotate function. So if we go down to rotate, we're just incrementing the rotation by the amount, and this should not be the case, because if we go up to our rotation, when we're setting a rotation, we're fixing the rotation between 0 and 360 degrees. So we need to use this function instead of just incrementing the rotation. So we'll go down here to our rotate, and instead of saying m rotation plus equals amount, we'll say rotation is going to be equal to m rotation plus the amount. So this is the only change that we need to do in the GameEntity.cpp, and that will be it. Now we can move on to our enemy.h. And in enemy.h, the epsilon value is actually way too low. I noticed that the enemies start to go back sometimes because we are doing, when we're checking the distance, we are checking the square of the magnitude. And the square of the magnitude being 5 means that the magnitude itself is really low. So we're going to change it to something like 50. That means that the difference between the point that we're trying to get to and the position can be around 7 pixels, which is acceptable, before switching to the next waypoint. So now that we have fixed this epsilon value, we can move on to the bulk of our code. And first, we need to change one more thing in the enemy.cpp. So in enemy.cpp, we need to go down to handle formation state. Let's see, where is handle formation state? There it is. And what we want to happen is that when the enemy goes to formation, we don't want it to snap back directly to 0 rotation. We want it to rotate over time to point upwards. And for that, we will say float rotation is going to be equal to our rotation. And then if the rotation is not equal to 0, we want to rotate so that the orientation is back to 0 degrees again. So if the rotation is more than 2, so we'll give ourselves an epsilon value of 2. So as long as it's more than 2, we want to rotate over time. Otherwise, we want to snap to 0 rotation. So if the rotation is more than 2, else, so in else, we'll say that the rotation needs to be 0 degrees. And that's all in the else section. Now for the rotation itself, we need a rotation direction. So we'll say float rotation dir is going to be equal to, and then now we need to, because if the rotation is 180 degrees, we need to go upwards. If it's more than 180 degrees, we need to keep rotating clockwise. If it's less than 180 degrees, we need to rotate counterclockwise. And that's what we're doing here. So the rotation, if the rotation is equal to 180.0f, so if it's exactly 180 degrees, we need to set it, we need the rotation direction to be 1. So 1.0. Otherwise, the rotation is going to be equal to, the rotation direction is going to be rotation minus 180. And the reason why we have this ternary operator is because if we do rotation minus 180 and the rotation is exactly 180, the rotation direction would be 0 and would be stuck without rotating at all. Okay, so now we can say rotate by rotation direction divided by the absolute of the rotation direction. And that should give us a normalized value between 0 and 1, or between 1 and -1 of whichever direction we need to rotate towards. And then multiply by M timer delta time, and then multiplied by, and we will need a rotation speed. So what we can do is go back to our enemy.h, or actually we don't need the rotation speed outside. We can just say, we can actually declare it in here. So we can say float rotation speed is going to be equal to 200.0f. And then in rotation speed, taking it from here, just paste it right here. So multiply by the rotation speed. And that will be it for the changes in here for now. We can now run it and see if the enemies actually, as soon as they get to the formation, rotate towards the 0 orientation. Nope, they seem to be snapping. So let's see what's going on here. Oh, right. So the issue here is the join formation function. So in join formation in the enemy.cpp still, we're setting the rotation directly to 0. So we want to remove that. Just delete this one and just set the formation position, the parent, and the current state, and that's it. So we just deleted the rotation equals 0. So let's run it and see what happens. There we go. So they're flying in. And there we go. So they go into the formation position, and then they just rotate over time to be in the right orientation. So that seems to be working pretty well. Now we can get started on our diving patterns. So we now need to move on to the level.h. And the level.h and level.cpp are the two files that we're going to be using the most in this video. So in level.h, we need to first separate the enemies into the 3 different enemies. So we need to create arrays for each enemy type. So we'll say butterfly pointer M formation butterflies. We need also a wasp pointer called M formation wasps, and a boss pointer M formation bosses. And as you might have guessed, we are going to be using these as the arrays for the formation enemies. So if we have an enemy that should belong to the formation, we're gonna add it to these arrays. And of course we need to turn them into arrays. So open bracket and then max butterflies. This will probably give an issue because it needs to be static. So we need to change our constant ints, the max butterflies, max wasps, and max bosses, to static. There we go. And this one as well. So just changing these 3 to statics, we can use them now to declare a size for our arrays. So this one will be max wasps, and this one will be max bosses. Here we go. Okay, now we need to start using these arrays instead of the enemy array. But we also need to figure out whether or not this is a challenge stage or not. So right here, right above formation, we can put a boolean M challenge stage. And in our XML file, we're already specifying whether it's a challenge stage or not. So we can use that and load it into this boolean. So if we go to our level.cpp and we go down to where we're loading the files, over here right underneath we can say that our challenge stage is going to be equal to M challenge stage is going to be equal to the fly or spawn patterns dot first child element, which is called level, and then first child element, and the first child element is the challenge stage, and then we want the Boolean attribute in that. So Boolean attribute, which is called value. And this should load for us whether or not this is a challenge stage or not. Now, if it is a challenge stage, we need to null all the pointers in our arrays that we just created, these 3 arrays. So over here, we will say that if it's not a challenging stage, or it's a challenge stage, we need to null out all the pointers. But we also don't need to set the formation if it's not a challenge stage. So over here, we can say, we can cut all this out. So the formation equal new formation, the formation position, and this, we can cut this out and put it in here. There's no point in creating a new formation if we don't need to use it. And then right underneath here, we'll say that for int I equals 0, I is less than max butterflies, I plus plus, and m formation butterflies at I is going to be equal to null. And then we'll do the same for the other 2 arrays. I is more than or less than the max wasps, I plus plus, and the formation wasps at I is going to be equal to null. And then for int I equals 0, I is less than max bosses, I plus plus, and then the formation bosses at I is going to be equal to null. So that should be it for initializing or nulling out all our arrays. Now we need to clear all this as well. So when we go to our destructor, over here we're nulling out or deleting the formation and nulling it out. So we can say over here, if it's not a challenge stage, we can take this in here, because we only need to delete this if it's a challenge stage because we create it. And then we will delete all the enemies and all the and null them out again. So we can just probably copy all these 3 for loops and paste them right here. And then we will add brackets for this now. So there we go. And then right before we null it, we can say m formation butterflies at I, or delete m formation butterflies at I. And then over here, delete m formation wasps at I. And then delete m formation bosses at I. And that will be it for clearing our, oh, looks like I deleted the bracket. Okay, and that will take care of clearing all the arrays that we just created. Now we need to also set our spawning to use these new arrays. For that, we will go down to where we're doing our spawning. So we will go down to our handles enemy spawning, and in here we will say that, so in here for our butterflies, if it's not a challenge stage, and then open bracket. So if it's not a challenge stage, we want to say that our m formation butterflies at the index is going to be equal to a new butterfly at this index. And so now we have our array, and the index of that butterfly that we have in our array is in relation to the index that we gave it in our XML file. So it makes it a lot easier for us to know which butterfly or where this butterfly is within the array. And then we can say else m enemies dot pushback a new butterfly. There we go. So if it's not a challenge stage, we want to put every butterfly in a formation array. If it's not a challenge stage, we will just add it to the enemies array and update it and render it and then clear it just using the one vector that we were using from before. So we'll do the same thing for the wasps as well. So if not challenge stage, we will take m formation wasps at the index is going to be equal to, and then we will just copy a new wasp index path false and false, and then we'll say else, and we will keep the enemies array in here. So that's what it needs to look like, and then the bosses will do the same thing again. So if not a challenge stage, keep in mind we only increment the wasp count, the butterfly count, and the boss count if it's not a challenge stage, because we need a specific amount of enemies for the formations. But in a challenge stage, it doesn't really matter, so we don't need to increment these values there. So we can say m formation bosses at the index is going to be equal to a new boss, so the same thing that's in here, and then else, and we will keep what we have in the enemies. And that will be it for this part. Now next up is the fly-in, because when we're flying in, we're checking all the enemies arrays, but this is not the case when we are doing our formations, because we're now using the formation arrays. So what we need to do is create a new function to check a fly-in, the fly-in for the enemies whenever they're going to formation. So in our level.h, we will go down here right above the handle enemy spawning, and we'll add a Boolean function called enemy flying in. And then back in our CPP file, we will go up to, let's see, it's right above handle enemy spawning. So we will go right above handle enemy spawning, and we will add this function in here. So over here, we'll say that Boolean level handle or enemy flying in, and then for int I equals 0, I is less than max butterflies, I plus plus, if the formation butterflies at I is not equal to null, and the formation butterflies at I current state is equal to enemy fly in. So if it's not null and it's flying in at the time, we need to return true, because it means one of the enemies is flying in. So we'll say return true. And then we will do the same thing for the other two arrays. So we can just copy this and paste it twice, but instead of max butterflies, we'll say max wasps. And instead of max wasps, and instead of formation butterflies, we will say formation wasps. But then we need to change it here as well. So formation wasps and formation wasps. And then over here for our third one, this one will be max bosses. And then this one will be formation bosses. And then this one will be formation bosses. So there we go. And all the way at the end, if none of these return true, we will just return false at the end. And that will be it for this function. Now we can start using it. So where are we using the fly-in? If we go down to the enemy spawning, in our, so if the priority is not found, we are saying that the spawning is finished. But if the priority is found, we are doing the flying in checking in here. So we can just remove the Boolean and the for loop and instead use our flying in function. So enemy, if not enemy flying in, and that will be it for this part. Now we can go down, and here we are doing a flying in as well in our handle enemy formation. So we can delete the Boolean and the for loop, and in the if statement we can say enemy flying in as well. And that will be it for this part. So here we're updating our formation. Next up, we need to update the formation, the formation arrays for each enemy. So right underneath formation update, we can go here and say for int I equals 0, I is less than max butterflies, I plus plus. And then, we probably don't even need the brackets. We can say if formation butterflies at I is not equal to null, then formation butterflies at I update. So now we're updating the butterflies, so we can copy this and paste it twice more, one for the wasps and one for the bosses. So wasps, and then formation butterflies, we need to change that to formation wasps, and we'll do the same thing for this one. So formation wasp and formation wasps, and then max butterflies can be max bosses here, and then formation bosses and formation bosses. And that will be it for updating our function. Now what we need to move on to is to check whether or not the formation is locked or not in here. So over here we can say if the formation, if not formation locked. So open bracket. So if the formation is not locked yet, what we want to do is to keep checking if the enemies are still flying in, and if they finished flying in, lock the formation. So we're just wrapping this if statement. We're wrapping it with this if statement right here. And then at the end, we can say else, if the formation is locked, we want to handle the enemy diving. So we can say handle enemy diving. And since we're handling the enemy diving in here now, we can go down to our update. And here in our update, we can say, we can remove our handle enemy diving, and then say in here if it is not a challenging stage. So if it's not a challenge stage, handle enemy formation. So the enemy formation now is only handled if it's not a challenge stage. Okay, so that covers most of the things that we need to go through so far. The only thing left is to do the rendering for these arrays. So now we can go down here, right above where we're doing our enemies render. We can say if it's not a challenge stage, we can actually go all the way up here to our handle enemy formation and copy all 3 loops from here and go down back to our render. And in our not challenge stage if statement, we can paste these 3 here, and instead of update, we can just say render. Render, render, and render. Okay, and that takes care of that. This is probably it for changing everything to run on our formation arrays. So we can probably run it and see what it looks like now that things are in place. So here we go. And now there shouldn't be a difference between what we had before and what we have now, but it will be useful later on when we're doing the diving. There we go, it seems to be spawning fine. And we just need to wait now for the last ones, and then the formations should lock. And okay, that seems to be working pretty well. Now for handling the diving, right now we don't have them diving yet, so let's implement that. Okay, so let's go to our handle enemy diving, and we can pretty much delete everything that we have in here. We can just remove everything because we had it set to use keys, but we don't need to do that anymore. And now let's start off with the butterflies. So what we need to do is to declare a few variables for the butterfly diving. So we'll go back to our level.h, and over here, right underneath the spawn timer, we can say a butterfly pointer, m diving butterfly, and this will contain the butterfly that's diving at the time. And then we will have boolean m skip first butterfly, and this boolean is going to tell us whether or not we should take the butterfly on the right or the left. And then we will have float m butterfly dive delay and a float m butterfly dive timer. And these are the only variables that we need for the butterfly. So let's go back to our level.cpp and go up to our constructor and initialize some of these variables. So we will go here and first set our butterfly diving butterfly to null. So m diving butterfly is going to be equal to null. And then m skip, the first butterfly, is going to start out being false. Our butterfly delay, dive delay, is going to be 1 second. And the butterfly dive timer is going to start out being 0. And that will be it for the four variables that we need to initialize. So that's inside our constructor. Now we can go down to our dive function. So handle enemy diving, there it is. And then here we can start implementing the diving behavior for the butterflies. So the first thing we need to check is whether or not the diving butterfly is null. So if m diving butterfly is equal to null, we need to increment the timer. So the butterfly dive timer plus equals m timer delta time. And then if the butterfly dive timer is more than or equal to the butterfly dive delay, then we need one boolean called skipped, which is going to start out being false. And we're going to use this to check whether we want to skip the first butterfly or not. And then we will loop through the butterfly array. So for int I equals max butterflies minus 1, because we're starting from the end of the array, I is more than or equal to 0, I plus plus. And then if m formation butterflies at I, current state is equal to enemy formation. So if the current state of the current butterfly is in formation, we need to send it to on a dive. But we only want to send it on a dive if we don't need to skip it, since it would be the first butterfly we meet. So if not m skip first butterfly, or between brackets now, m skip first butterfly and already skipped. So if we don't need to skip the butterfly, or if we do need to skip it and we already skipped the first butterfly, we need to send the current butterfly on a dive. So we can say m diving butterfly is going to be equal to m formation butterflies at I, and then m diving butterfly dive, so we just tell it to dive, and then m skip first butterfly not equals m skip, or equals not m skip first butterfly. So we just reverse the boolean that we have. And then after this one, we just break out of the loop. So that will be it for the logic for sending either the first one or skipping the first one. But right underneath here, right underneath this if statement, we can set skipped to true. So if we go into the if statement, we're breaking out of the for loop, so that's fine. If we don't go into the if statement, we set skip to true because we just skipped the first butterfly. And then since skip is true, the next butterfly that comes through will be the one to be set to dive. So this will be it for this part. And then over here, right before we exit this if statement, we need to reset the timer back to 0. So we can say m butterfly dive timer is going to be equal to 0.0. Okay, so now we need to deal with the butterfly, the diving butterfly, if it's not null. So over here we can say else, if it's not null, we need to figure out if it's finished diving or not. So we can say if the diving butterfly current state is not equal to dive, so enemy dive, we can say that our diving butterfly is going to be equal to null once again. So if the enemy is killed or it finished the dive, we set the diving butterfly back to null again, so that we can pick the next butterfly to dive. And that will be it for the butterfly. So let's see if it works. So once the formation logs, we should see this butterfly dive and then this butterfly dive afterwards. So there we go. This one starts diving, and then once it's in its place. Oh, something is wrong here. Okay, so it seems like it's sending the wasp to dive, which is odd. What happened here? Let's see an enemy spawning. So if it is a wasp, formation wasps, or the enemies are pushed back. That seems fine. So, that's interesting. It is sending a wasp to dive. So let's run it again and see what's going on. There we go. Okay, so we have our formation butterflies here, and they are all butterflies. Okay, so let's continue that. And there is the first butterfly to dive, and then it should send the next butterfly, which it thinks that it is a wasp. That's interesting. So that is this one, and then I is equal to 16. So when I is equal to 16, why is it a wasp that is diving? I is equal to 16. 16 minus 1 should be 15. Why is I equals to 16 here? Let's pause it again. Let's stop it for a second and then go right here. Okay. The issue here is that it thinks that, oh, that's why. Okay. Okay. I'm doing I++. It should be I minus minus because we're going backwards. That was an interesting mistake. And I guess the two arrays were back to back, so it's hopping over to the first index of the wasps. That's pretty interesting, actually. But that should be it, though. There we go. So now it should spawn all the enemies, and then now it should have the right butterfly dive first, and then the left butterfly dive next. There we go. Now we have this butterfly diving down. And next we have this butterfly diving down. Okay, so that seems to be working, and they're looping between these two butterflies. When this one dies or something happens to it, it should start sending down, I believe, this one, and so on. Okay, so now that we have the butterflies working, we can move on to our wasps. So for the wasps, we usually have two wasps diving at the same time. So for that, we will create the variables for these. And these variables will be a wasp pointer called mDivingWasp and a wasp pointer called mDivingWasp2. And then float mWaspDiveDelay and a float mWaspDiveTimer. Okay, now that we have the variables that we need, we can go back to our constructor and initialize these variables. So we'll go up to our constructor, and in here we will say that our diving wasp is going to be equal to null. Our diving wasp2 is going to be equal to null. And then our diving wasp delay will be equal to, what do I have it here? 3. So our diving wasp delay, or wasp dive delay, is going to be equal to 3.0f. And our wasp dive timer is going to be equal to 0.0. So now that we have these variables initialized, we can go back down to our handle enemy diving function and implement our wasp diving. So we will go down here, and underneath the butterflies we can say that our wasp dive timer is going to plus equals mTimer delta time. And the reason why it's outside an if statement for the null statements is because we have two wasps diving at the same time. So we can't just limit it to whether or not one of them is null. So we can say our wasp dive timer plus equals timer delta time, and then if the wasp dive timer is more than or equal to the wasp dive delay, and then let's just add the reset for the timer right away. So mWasp dive timer is going to be equal to 0.0f. And then above it, we can loop through the array and find the wasps that we want to dive. So for int I equals our max underscore wasps minus 1, I is more than or equal to 0, and then I minus minus. Don't want to make the same mistake twice. And then if the formation at I the formation wasps at I current state is equal to enemy formation, what we want to do is to check whether the first diving wasp is null or not. So if m diving wasp is equal to null, then this is the one that's going to be assigned to dive. So m diving wasp is going to be equal to the formation wasp at I, and then the diving wasp, we're going to call its dive function. And then else, if the diving wasp 2 is null, we want to assign diving wasp to the formation instead, and then make it dive. So m diving wasp 2 is going to be equal to the formation wasps at I, and then diving wasp 2 dive. Nope, not dead, dive. And then right after the if else here, we will just break out of the loop because we found the wasps that we want to dive, and then we just break out. Okay, now we need to figure out how to set the diving wasps to null, just like we did with the diving butterfly. So underneath this if statement here, we can say that if the diving wasp is not equal to null, and the diving wasp current state is not equal to enemy dive, then we want to set the diving wasp to null. And we will do the exact same thing to the diving wasp 2. So if the diving wasp 2 is not equal to null, and the diving wasp 2 current state is not equal to enemy dive, then our diving wasp 2 is going to be equal to null. And that will be it for the wasp diving. So let's run it and see what it looks like. There we go. So the formation is now finished, and then we have our butterfly diving here, and then we have our wasp diving here, and then before it finishes, the other wasp starts diving, and this butterfly is diving as well. So it seems like we have almost all the pieces in place. We just want the boss diving pattern now, and that will be it. So here underneath the wasp diving, we can add the boss's diving pattern. So we can say if, or we probably need the variables for that. So we need to go back to our level.h, and the variables for this will be a boss pointer called m diving boss, and then a boolean for whether or not it's a capture dive, so capture dive, and then a boolean for m skip first boss, so just like for the butterfly, and then a float m boss dive delay, and a float m boss dive timer. And with that, we can go back to our level.cpp, initialize these variables, so we can go back to our constructor and say that our m boss, our diving boss, is going to be equal to null. Our capture dive is going to start off being true, and then our, what else did we have here? Our skip first boss is going to be equal to true, and then our boss dive delay is going to be equal to 5.0f, and the boss dive timer is going to be equal to 0.0. And that will be it for initializing the variables that we have. Now next up, we can put in the logic for the boss diving. So we go back to our handle dive enemy diving. There we go. And over here, we'll say that if our diving boss is equal to null, what we want to do is increment our boss dive timer. So m boss dive timer plus equals m timer delta time. And then if the boss dive timer is more than or equal to the boss dive delay, we will have a boolean called skipped. So the same idea behind the butterflies is going to start out being false. And then if or for int I equals max underscore bosses minus 1, I is more than or equal to 0, and then I minus minus. If m formation bosses at I if the formation bosses at I is current state is not equal to or is equal to enemy formation. So if the boss that we're on right now is in formation, we want it to start diving. So if not m skip first boss, or between brackets m skip first boss and skipped, we want to make this the current boss dive. So we will say that our m diving boss is going to be equal to the formation bosses at I. And then if it's a capture dive, so if m capture dive, we will say that our m diving boss dive, and we'll give it a parameter of 1, which is our capture dive for the boss. Else, what we want to do now is make it dive normally, so we can say m diving boss dive, and it's 0 by default, so that's fine. Then we want to also find the indices of the butterflies that are diving with it, because this is an escort dive. So int index is going to be equal to our diving boss's index, so m diving boss index, and then int first escort index is going to be equal to our index modulus 2 is equal to 0. This one should be called index. So index modulus 2 is equal to 0. Index times 2. Otherwise, index times 2 minus 1. So this is pretty much the same thing that we had from before, where we had our key presses to make the boss dive, but now we're implementing it in here. And then int second escort index is going to be equal to the first escort index plus 4. And us having all the butterflies in an array by themselves now makes it a lot easier to find these indices by saying that if the formation butterflies at the first escort index is not equal to null, well, actually it's never null once we start diving, because the formation is ready. So we can just say if the formation butterflies of the first index in its current state is enemy formation. So if this butterfly is in formation, we can say m formation butterflies at the first escort index dive 1. And we're given a 1 because we're telling the butterfly now that this is an escort dive, not a normal dive. And then we'll do the same thing for the second escort index. So we can just copy the if statement here and paste it again, but then copy the second escort index and replace these two indices right here. So that covers the 2 butterflies that are going to be coming down with the boss. Now, right outside this if-else statement, we need to say that our skip first boss is equal to not skip first boss. So mskip first boss, just to flip that boolean. And our capture dive is going to be equal to not mCapture dive. So every other dive is going to be either an escort or a capture dive. And then right underneath here, we can just break. Now, for here, we can say that, or right here. So if we don't go into this if statement, we need to set skip to true. So right after this if statement right here, so right over there, we can say our skipped is equal to true. There we go. And then, oh, deleted that bracket by mistake. And then over here, what we need to do is to reset the boss dive timer. So right here, we will say m boss dive timer is going to be equal to 0.0f. Then finally, we need to find a way to reset the boss time, but the diving boss back to null. So we need, for this if statement, we need to add an else. So we'll go down here and say else. If the diving boss current state is not equal to enemy dive, and for the reason why we're using enemy dive is because the enemy might die mid-dive, so we might as well just set it back to null as soon as they die as well. So if the enemy is not diving anymore, we can say mDiving boss is equal to null. Okay, so that should cover it for the bosses. So let's run it and see what that looks like. There we go. And then finally the last last wasps in, and then once that's ready, we have our butterflies coming down, a wasp coming down. There we go, a boss coming down for a capture. And then there we go. When the boss goes back here, we should have another boss a little bit after come down with an escort dive. There we go. With 2 butterflies going off screen and then coming back, and then we should have another capture dive. So that seems to be working pretty well. The lines are pretty annoying, so let's remove the lines now. For that, we will go to our, where did we have the lines? For boss.cpp. In boss.cpp and render, I believe render dive state. There it is. We can just remove the for loop right here. There we go. So we just keep the textures at 0 render and the capture beam. And then in our butterfly.cpp, we'll go to render dive state as well. Render dive state. We can just, let's see. We can just delete everything here and just render only the texture at 0. And then for the wasp, where is the wasp now? There it is. We can go down to our render dive state. We pretty much can remove everything here except the texture at 0 render as well. Okay, and that should remove all the lines that we have rendering for the dive patterns. And let's see what now the game looks like without the debug lines. Okay, so once they start diving now, there we go. So we have those ones diving down, so that looks pretty good. And then the boss coming down to dive. Yeah, and I think that looks pretty good. The only thing that's kind of bothering me is that the wings of the wasps on this side kind of get chopped off, and there's empty space over here. So maybe we can move the formation a little bit to the left. And to do this, we can go to our formation.cpp, and let's see where we're setting our position. Or maybe we're not setting it in here. Maybe it's in level.cpp. I think it was in the constructor. Yes. So in our level.cpp in the constructor, we have here formation position, and we're setting vector to width times 0.4. So let's say it's something like 0.39 or something like that. Let's see what that looks like. So that should move a little bit to the left. Hopefully that doesn't break anything else, but I don't think it should. We don't really have anything set to depend on the formation position really, except for like when the enemies are in formation. There we go. Yeah, so that looks pretty good. So it doesn't seem to be chopped off here, and it doesn't reach the end here as well. And then there we go. So we have a boss diving down with a capture beam, goes back in place, and then after a few seconds, another boss is going to go with an escort dive. There we go. And now we have it set that if one of them dies, the next one should take over, because it looks for an enemy information at the time. But yeah, that should be it for this video. I really hope it helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.